is leading the way with the geared turbofan technology and high-performance military engines. This success of these programs depends greatly on their world-class supply base. The present and future demand is challenging their current supply base capacity, including titanium suppliers, and offers future growth to those that can stand up to the challenge. This discussion will outline Pratt & Whitney's present and future demand, what it means for their suppliers, and the requirements to be a part of Pratt & Whitney's success. Bill Reed is Pratt & Whitney's Associate Director, Forgings, Airfoil, and Structural Castings and Mill Products Strategy, as I mentioned. And in this role, Bill is responsible for leading the team that establishes the long-term strategy and contractual negotiation of these products and the manufacture of Pratt & Whitney products. In addition, Bill's team manages and directs the sourcing of the billets for those forgings and melt stick for casting used by Pratt & Whitney US. Finally, his team is responsible for metals industry analysis and managing costs via elemental strategies for elements that are used for billet and cast melt stick alloys. Please help me in welcoming Bill Reed.
Well, that was a whole lot of words to say that we're a purchasing group and that we love our supply base. So I'd like to thank the ITA for giving me this opportunity to speak. I hope there'll be something in there that is meaningful to you and that there could be future opportunity. As I look out across here, you know, I've got a mixture of anticipated excitement and nervousness because I've got a number of my suppliers out here, and I hope I haven't really ticked any of them off because they could really get even with me now, but I'm going to trust them to be good to me, okay? So the first slide, which the lawyers make me go through, I can summarize in a few words. That said, there's going to be some forward-looking statements in here, and if you're foolish enough to invest your money in anything I say, then you're on your own. Good luck to you. Okay. So what are we going to do for the agenda today? As Viv introduced, yeah, aerospace is back. Pratt & Whitney is leading the way with our airframer partners, led by, on the commercial side, our geared turbofan technology. That's a game changer in the industry, reducing fuel burn, flying jets much quieter. It's really making a difference in the world. It's been these engines have been welcomed by the airline community, and we are actually selling well ahead of where we originally anticipated. We're sole source on our F-135 engine platform that goes on the Joint Strike Fighter, an incredible piece of machinery that we're very proud of. But that brings opportunities for the supply base. So what does that really mean to our supply base? We are only as good as our suppliers, and we are looking for world-class suppliers that can keep up with our pace. We are adding suppliers into the Pratt & Whitney family. As I look out, there's a couple that are here this morning that we're bringing on into our supplier family to get on these growing platforms, and there are room for others if you can stand up to the challenge. Okay, so with that growth that we're all seeing, cost pressures apply, and that poses a threat to our titanium supply base. As our costs rise with the demand throughout aerospace, we see challenges to innovate on materials and bring new materials into play. And then I'll go through a little bit of what we're seeing as our projection for titanium usage over the next few years, and comparing that to other alloys that we use within our engines. So how do we manage our supply stream? How do I task my team to move forward and manage our raw materials? We look at our supply chain we like to say from the ground, from anything on the periodic table through delivery of that engine. And this just really looks at this slide really just looks at how we manage the raw materials on my team. We will, in some strategic instances, actually work with metals traders, and we will contract for strategic elements that go into the alloys that make our engines. We also contract for those alloys, our nickel-based alloys, our titanium alloys, and we will direct, in some cases, our casters, and in most cases, our forgers, to go buy off of our mill contracts. And on top of that, we will have, obviously, contracts with our casters and our forgers, directing our machine shops to buy from them. So it is a full full value stream strategy that we employ at Pratt & Whitney to control our costs and to secure the capacity that we need. So, what are we looking at for that security of supply? We will aggregate our demand, and we drive materials forecasts through our entire supply chain, from the finished engine to machine part, all the way back to the mills themselves. We will maintain, part of our contractual requirements that we flow to our suppliers is we will want strategic buffers on specific parts. Looking at titanium, we will buffer at an ingot level. Looking at a casting or a forging level, we will ask our suppliers to build ahead. We'll always want a 30-day build ahead on ground, or buffer strategically for all the inputs that go into their process. And then we will execute long-term agreements. And this has been something that's changed over Pratt & Whitney over the last few years. For us, long-term, back into the late 90s, early 2000s, long-term for us was a 3 to 5 year contract. We're contracting for much longer than that now. Now, 10 years is usually what we're going for, with an appetite to go even longer. Capacity is constrained. We want to secure our unfair share of that capacity. Now, I'd be remiss as a purchasing guy not to talk about cost, okay? As capacity gets constrained in our supply base, costs rise, lead times will expand. We negotiate for long-term cost. We are not in the business, although I've been accused of this, of trying to take away your margin. If I had $1 for every supplier that I said I had close to bankruptcy, I really wouldn't be standing here right now. But we do compress price. We want a fair price for the business that we're going to be giving you, and for the long-term commitment that we're going to be giving you. We drive that cost transparency through our contracts. I understand in a metals industry, there are costs that are beyond our control. We are subject to market influences that other industries are not. We fully intend and work to make our supply base whole for those costs that they can't control, but that's not an opportunity for the supply base to take advantage of that and put adders on top of those. So that is one of the reasons that we will actually contract all the way through our supply chain. And then as I mentioned, we will direct our suppliers all through the supply chain to buy from each other. That's something that's required within our contracts. And then finally, this doesn't apply to titanium as much as to our nickel-based alloys, but we will ask for the ability to hedge with you, whether you do a buy ahead for us to protect on an elemental level, or we do a financial hedge together. We want to be able to control that cost. So how can our metal suppliers differentiate themselves for Pratt? Again, offering the long-term contracts, the ability to stock and offer price stability. Price stability to us means that we are looking for firm pricing long-term. Again, we will protect you as best we can between our businesses for those cost fluctuations, but the guys that come to the table and offer me the best value, the firm pricing over time, are the guys that are going to win the contracts with us. Additionally, allowing us to lock our element prices with you, as I had said earlier. If you expect to pass through your cost increases to us, we expect you to give us a chance to control our own destiny. I've had many suppliers in the past push back saying that they want to manage their metal themselves, okay? They can aggregate, and I understand you've got other customers and you want to aggregate that business and secure the best savings that you can there. But then in that instance, I don't expect you to be able to pass through any price fluctuation that you're seeing to me. If I'm going to be absorbing that price fluctuation, I expect that I should be able to have an opportunity to control my own destiny. So the big things for us are that firm long-term price, okay, the ability to lock and the ability lock the elementals, and the ability to have you stock for us and build ahead so that you're not running out of material. So, other considerations that we put in when we're considering somebody, we weigh how we operate internally versus the suppliers we consider. So when we're looking at price blocking for metals, it's important to look at where you fit in that supply chain. If you're a mill or a forger or machine shop, or are you an assembly house? This dictates your strategy on commodity prices as a percentage of your cost of goods sold, and it's greatly impacted based on what you produce. What do you use, and how much of it do you really use? So that sounds easier than it is to accomplish, especially when you're an assembly house or an integrator level. And there are many factors that go into the yield ratios or the input or output materials that really dictate what you use in the composition that constantly affects those changing designs. I love to be able to tell you that when we go to market with an engine that our designs are frozen. Not true at all. We are usually making changes well into years once an engine is introduced into service. And then your fiscal exposure. You know, I'd be remiss if I didn't try to control these costs. I'd probably be looking for a new job if I allowed prices to fluctuate with a market. But actually, in some instances, it may be advantageous for us to float with market. And those are things that we like to discuss and work with our suppliers on. So let's move more specifically into titanium. Titanium, historically, it's been highly valued by aerospace, especially due to its high strength to weight ratio. But as more competitive alloys are introduced and developed into the market, it's becoming more and more challenging for titanium to keep its stronghold. So what are the threats that we have to titanium? We at Pratt put a lot of high-strength isothermal forging discs based on nickel-based alloys into our engines. That has displaced some titanium in some stages of our engines. If you look at aluminum is a growing threat to titanium. Traditionally, our fan blades have been all titanium. The new geared turbofan, primarily all aluminum-based fan blades now. So that as aluminum gets stronger, it's causing an effect on titanium in a reduced market for that commodity, and we'll show that a little bit when I show you the forecast that I have on our alloys. Other threats that we have, potential tariff actions on titanium input materials. There's discussion now of under Section 232 that my friend just spoke about here. There's talk about putting that on titanium sponge that's not produced in the United States. A lot of action and inquiry going on around that right now. That would drive costs. Drive cost up, it encourages the OEMs to go look at alternative methods of manufacture, alternative alloys that could displace where our cost is rising. So those are very real threats to titanium. Henry Seiner yesterday spoke about the regulatory impacts in the EU through the environmental efforts and what are the effects those will have on aerospace. These are all things that have to be considered and addressed by folks in the titanium industry and in all metal industries. So the bottom line on this is titanium has its opportunities, it has its threats. The use of titanium is increasing in composite aircraft. New applications and designs incorporate some more advanced titanium alloys that are getting developed. But on the downside, the next generation engine architectures are challenging titanium. As I mentioned, changes to aluminum from titanium, and the alternate materials that we mentioned tend to erode that titanium use. So the need is to continuously improve and advance those technologies in titanium in order to maintain the same foothold. So again, what we really look at here from a titanium perspective, the high strength and the lightweight systems, the manufacturing costs. We talked a little bit earlier today, Mr. Carpenter spoke about the capturing of revert. Admittedly, that's not something that we actually do very well at Pratt & Whitney. It's something that we have to get much better at capturing our revert, just not on titanium alloys, but even on our nickel-based alloys. Need to recover those from our overhaul facilities and get those built back into our contracts so that we are actually sending scrap to our mills so that we can drive our costs down. That's something we need to work together with our mills. The more durable coatings may be applied to titanium blade tips, which could increase the life of the blade. This would lower the consumption of titanium. So, there's also internal threats with technology from coatings that could challenge titanium. And again, if a cheaper process comes along, we're always going to listen to it. See, those advanced materials are very critical, and if we look at innovations over time, and how fast innovation occurs, that really drives home the nimbleness we need from all of our supply base to develop the next best thing for us. If we even look at different industries or different aspects of our life over time, we look at communications, right? It took 400 years to get from the Gutenberg press to the telegraph, okay? But then only 32 years from there to get from a telegraph to a telephone. Things happen rapidly. And now we carry mini computers in our pockets. We have an age of children. I have 2 grandchildren under the age of 6 who don't know what it's like to use a telephone where they can't look at your face. If I call them without using FaceTime, it's like, Grandpa, why are you doing this? I can't see you. And it's really kind of fascinating. Anyone with teenagers, how quickly do they pick up their phone if you call them? They'll usually ignore your call, right? But you can text them at any time and get an instant message. My youngest son right now, as an aside, is in Amsterdam on his way to Munich, 26 years old, going to go enjoy his first Oktoberfest. Hopefully will return safely in October, but we'll see. Texting him, the time difference that we have, I can communicate with him instantly now. Whoever thunk it, and what's the future hold? But if we look at jet engine manufacture in the history of flight, just briefly, it took 120 years to get from the first hot air balloon flight to the Wright brothers. Okay, then it took you 73 years to get from the Wright brothers to the Concorde, and then from the Concorde 40 years to the geared turbofan. How many years until we're actually flying an electric jet that doesn't need any jet fuel? These are innovations that we very well could all see in our lifetime. So, what's going to happen with the innovation in titanium? Can titanium develop alloys, advanced alloys that will start to displace our nickel-based alloys? As you'll see in a moment when I put up the forecast, nickel-based alloys far outpace any other alloy within our engine, far outpaces titanium. In fact, let's just go over to that. We'll take a look at what we're going to see in growth over time. In this year, we are going to see in our engines well over 9 million pounds of nickel-based alloys used throughout our engine, from our turbine airfoil castings all the way through our nickel-based isothermal forgings and then more traditional conventional forgings. That is trailed, it's really trailed distantly with the orange columns with our titanium usage. And what's really telling about the titanium usage here is if you go and you drop to the next level, the aluminum usage that we use in our engines, frankly, guys, that's pretty much all fan blades right there, that volume of aluminum. So that bar used to be stacked on top of the titanium bar, okay? That used to be titanium. So the threat is real. We need innovation throughout our supply chain to make the alloys that are going to launch us into the future. So in summary, titanium, it's significant. It's still significant. It will be significant for years to come. Threats to it? Yeah, there are threats to it. I hope I've demonstrated that to you. Primary threat being aluminum, but then you can threaten the other alloys that go into our engines through your innovation. Titanium has the opportunity to maintain and grow through its innovation in capability and cost, and supply must be reliable. I'm going to circle back to my supply chain hat. I need everything I need. It's really simple. I need perfect quality on time every single time. If you can execute that, you have got a great future with us. I want to thank you for letting me speak this morning, for listening, and I hope I've resonated with some of you. To my new suppliers that are coming on that are watching, thank you for your interest in Pratt & Whitney. We look forward to a long, bright future. To the guys that we've done business with for years, let's continue to do it and knock it out of the park as you always have. So thank you very much.